Hi and welcome to this Junior Cycle Higher Level Maths Revision video. Today we're going to focus on some algebra word problems and in particular quadratic equations. So to do this we're going to use some past Junior Cert exam questions and also some of the 2020 Junior Cycle sample assessment items. So the first question is from the Junior Cert Higher Level 2014 Paper 1 question 11. X is a real number. So remember, a real number is any number on the number line. One new number is formed by increasing x by 1. A second new number is formed by decreasing x by 2. Write down each of these new numbers in terms of x. Now, be careful. If you increase something, you're talking about increasing it, making it bigger, adding on. So an increase by 1 is adding on 1. So increasing x by 1 is x plus 1. Decrease x by 2 is x minus 2. Just be careful. Sometimes when you hear the word by, you might go straight to multiplication. That's not correct. So we would talk about the word times. When you see times, that's when multiplication comes into play. Increasing and decreasing tends to be adding and subtracting. The product, okay, so product is the answer when we multiply. The product of these two new numbers is 1. Use this information to write an equation in x. So when I multiply x plus 1 by x minus 2, the answer is 1. So it equals 1. Use this information to write an equation in x. Okay, so this is my answer. If you want to expand it, and we'll need that expanded and simplified for our next part, so we can multiply out these brackets. Officially, yes, you have written an equation, but let's multiply it out. So this is what I have, x plus 1 times x minus 2 equals 1. We'll split the bracket. So we get x times x minus 2 plus 1 times x minus 2 equals 1. That gives us x squared minus 2x plus 1x minus 2 equals 1. And we get x squared minus 1x minus 2 equals 1. So what we actually have here is a quadratic. So because it has an x squared, we know it's quadratic. We actually have a quadratic trinomial, but if we have a quadratic equation, it should always equal 1. Or no, it should always equal 0. This one equals 1. So we want to get rid of that. So what I'm going to do is I'm going to take away a 1, but I need to take it away from both sides. So my final quadratic equation in the form that we're used to working with it is x squared minus x minus 3 equals 0. And you can put that 1 in the middle or you can leave it without a 1. There's no issue. So either the first step we had, that's perfect, but you're going to need to expand this out for the next part anyway. So the next part was solve this equation to find two possible values of x. Give each of your answers correct 3 decimal places. So if you hadn't expanded your brackets and simplified, now is where you would need to do it. I've already done that, so I have x squared minus 1x minus 3 equals 0. It told me to give my answers correct to 3 decimal places, and this is a big hint. This is the hint that we have to use the quadratic formula, also known as the minus b formula. So let's use this minus b formula. So to do that, we have ax squared plus bx plus c. So a equals 1. It's the coefficient of x squared. B equals minus 1. Watch your signs. The coefficients have to take in the signs. And c equals minus 3. The formula is x equals minus b plus or minus square root b squared minus 4ac all over 2a. That is x equals, remember to always use brackets with your substitution, minus minus 1 plus or minus square root minus 1 squared, especially when you're squaring negatives. Remember, the calculator may not give you the correct answer if you don't enter it properly. That's why the bracket is so important. All over 2 times 1. Let's simplify this. Minus minus 1, it's plus 1 or just 1. Square root of minus 1 squared is 1. So minus 1 by minus 1, minus by minus is plus. Here we have minus 4 by 1 is still minus 4. By minus 3, it's plus 12 all over 2. So we get x equals 1 plus or minus square root of 13 over 2. Now, we need two different answers. The first answer is when we put the plus in. So that's x equals 1 plus root 13 over 2. We want that correct to 3 decimal places, so you can put that into your calculator. Plus root 13 over 2. Press your S to D or change button depending on your calculator, and we get 2.30, and then it's 27. So this will round to 3. So when we look at this, we always look at the next number. I'll actually put this in so you can see it. So we have 2, 7, and then ... So we'll cut it after 3. We look at the next number. The next number is above 5. So 5 or more means we go up. We round up. So it's 303. Minus, so it's going to be x equals 1 minus root 13 over 2. Just a little trick. Don't clear your calculator. Use your back arrow to go in and change that plus to a minus to save you typing it all again. We want a decimal, so we want to press S to D or change. I get 1.3027. 3 decimal places means we cut it, and look at the next one. We get minus 1.303. So this question is from the Junior Cycle Assessment, Sample Assessment Items that were released in 2020. I start with 2 consecutive integers. Okay, so language is so important here. Consecutive means one after the other. So for example, 4 and 5 are consecutive numbers. So we have consecutive integers. What we know about consecutive numbers is that if we are talking integers, which are positive or negative whole numbers, the difference between them is 1. Okay, so I square each of them, then I add the 2 squares together. Use words, letters, diagrams, and or numbers to prove that the total must be an odd number. Now, what we're going to start with is our first number. So the first number, I don't know what it is. Let's call this x. Now, the second number, because I have 2 consecutive integers, the second number is going to be either 1 more or 1 less. It doesn't really matter. I think it's easier to do plus 1 instead of messing around with a negative, but we'll get the same answer either way. So we have first number is x. Because the second number is consecutive, we can write that as x plus 1. So that's my 2 consecutive integers. I square each of them. So this is x squared. This is x plus 1 squared. Then I add the 2 squares together. So I have x squared plus x plus 1 squared. And I want to prove that the total must be an odd number. Now, I'm going to stick to working with this as an expression because this is word problems to expressions. You can also look at using diagrams or lots of other ways that you can approach it. So the first thing I'm going to do is I'm going to square out this bracket. So squaring means multiplying by itself. So this is x plus 1 by x plus 1, which gives me x squared plus x times x plus 1 plus 1 times x plus 1. I'm just splitting my bracket. We have x squared plus x squared plus x plus x plus 1. Tidying that up, I'm going to add like terms, and we have 2x squared plus 2x plus 1, which is quadratic. And we want to prove that the total must be an odd number. Okay, so can I say for sure that this expression, 2x squared plus 2x plus 1, is odd? And I can, because 2x squared, 2 times anything, means I'll end up with an even number, because the definition of even means it's divisible by 2, and divisible means you can divide 2 in and there's no remainder. So this part here is an even part. This part here again is 2 times something, so it's again even. If you add any two even numbers, you'll still get an even number. Okay, so think of any two even numbers, 10 and 10, 20, still even. But we then take our even answer. So remember, this thing here combines. When we add them, no matter what x is, we're going to get an even number. But then we add 1. So we're going to add 1 to an even number. So when you add 1 to any even number, you're going to end up with an odd number. Because if you think of any even number, the next number is odd, because our integers go even, odd, even, odd, even, odd, even, odd. So therefore, we've just proved that this thing would be odd. This is from the Junior Certificate Higher Level 2016 Paper 1. 3 bags are shown in the table. The mass of each bag in kilogram is also shown. So we have the first bag, which has a mass of y plus 5, where y is a real number. See, it tells us here. The second bag has a mass of 19, so it's given to us. And the third bag has a mass of 2y squared plus 1. So although this has a good few pictures, it is still a word problem. 2 of the bags have the same mass in kilograms. So find 3 possible positive y values. Give your irrational answers correct to 2 decimal places. This is important, and I'm going to come back to it in a second. Okay, so there's 3 bags. So I'm going to label them just for ease. Let's call this bag 1, let's call this bag 2, and let's call this bag 3. So if 2 bags are the same, either bag 1 equals bag 2, bag 2 equals bag 3, or bag 1 equals bag 3. Okay, so there are 3 different options. If bag 1 equals bag 2, we make an equation y plus 5, bag 1, equals bag 2, which is 19. We can then solve that by taking 5 from both sides, which gives us y equals 14. Now, bag 2 equals bag 3, so that's 19 equals 2y squared plus 1. I don't like having my unknowns or my variables on the right, so I'm going to flip this. It's the same as saying that bag 3 equals bag 2. So we get 2y squared. Oh, I'll do vertical balancing here. So I'm going to take away a 1 from both sides. And when I take away a 1 from both sides, I get 2y squared equals 18. Divide both sides by 2 and you get y squared equals 9. Now, there is actually 2 possible values for y. So y could be 3 or it could be negative 3. So really there's 2 answers. However, because this is about weight and they've told us positive values for y, we only have to worry about the positive answer, which is y equals 3. So there's answer number 1, here's answer number 2, and our third answer comes from bag 1, y plus 5 equal to bag 3, y squared plus 1. Again, I'm going to flip this because I want to have my y squared on the left. You can work with it otherwise, but it just makes life a bit easier. I'm going to take away a 5 from both sides. And when I take away a 5 from both sides, we get y squared minus 4 equals y. I want to move that y as well, so I take away y. Now, there's nowhere to take that y away from, so it's going to just sit itself. So what I mean by that is it's going to be 2y squared minus y minus 4 equals, and then a 0. Now, what we have here is a quadratic trinomial, so we're going to have to solve this. Now, go back to this statement that I highlighted at the very start. It said, give your irrational answer correct to 2 decimal places, which means if we're going to work with this particular answer, it's going to require the minus b formula. Okay, so this was a hint. This was telling us if we get a quadratic trinomial that we'll have to use minus b. Now, I usually have, and I'll put it in, ax squared plus bx plus c equals 0, which is what's given in the log tables. It's not x's, it's y's in this case. So you can simply, instead of the x squareds and the x, put in a y squared and a y. It's still the same formula. A equals 2, b equals minus 1, c equals minus 4. And we're going to then solve that. One suggestion I have, because they're y's, is rewriting the formula as y equals. It's a very simple change, but actually it's a good habit to get into, because otherwise, especially as we get into harder questions, not necessarily junior cycle ones, but into maybe 5th year, this will become really important. So it's a good habit to get into early. So because the variable is y, I've changed the formula from x equals to y equals. So here we have y equals minus b, so minus minus 1 plus or minus square root of b squared minus 4 times a times c all over 2a, which is 2. Tidying that up, we get y equals 1 plus or minus the square root of 1. Minus 4 by 2 is minus 8. Minus 8 by minus 4 is plus 32. That's all over 4. So that gives us y equals 1 plus or minus square root of 33 over 4. Let's get our two answers, 1 with plus, 1 with minus. And we want it again, remember, correct to 2 decimal places. So it's press the fraction button, 1. We'll do plus first, square root of 33 over 4. When we do this correct to 2 decimal places, we get 1.686, which goes to 9. 1.69. And coming back here, changing it to a minus, S to D, or change, gives us minus 1.86, which is, 1.186, which is 1.19. So there are two answers. Y can't be negative. So remember, positive values of y, so this value of y is 1.69. So part B, explain why all 3 bags cannot have the same mass in kg. Well, here's our 3 values of y, and our y values will depend on which 2 bags have the same mass. there is no way that all three of them can have the same mass. Because if we look at this one, this is, and I'll go back to labeling 1, 2, and 3. So this was where bag 1 equal bag 2. And then this is where bag 2 equal bag 3. So if we wanted this first bag to equal 19 and the third bag to equal 19, it'll require different y values. So because they can't all equal the same amount with the same y, then this cannot be the case. So the simplest way to explain it is because each value of y is different. We would find that there will be a single y that could make them all the same, but that's not the case. Each value of y is different. Okay, so think of it in the simplest terms with just the first two. So if I wanted the first bag to be 19, the second bag is 19, and the third bag to be 19, then we would actually find that there is no y value that would allow those all to be the same. Another way to look at it is if we talked about bag 1 and bag 3 and sub that back in 1.69, it's definitely not going to equal 19. So it can't equal the second bag. Now this is a Junior Certificate Higher Level 2014 question. It's from the sample paper. A rectangular site with one side facing a road is to be fenced off. The side facing the road, which does not require fencing, is L meters in length. The sides perpendicular to the road are X meters in length, and the length of the fencing that will be used to enclose the rest of the site is 140 meters. Now, a good trick when we're doing any of these very wordy questions, when they also come with the diagram, is as you're reading through the paragraph to look at the diagram and make sure that everything that they tell us is on the diagram. So, a rectangular site with one side facing a road, that's given to us in the diagram. It tells us that the side facing the road does not require fencing. Okay, so when we look at the picture, the diagram, we're only looking at the black lines. They tell us that's L meters in length, which again is on my diagram. The sides perpendicular to the road are X meters in length. So they've given us one of those, and we know that opposite sides in a rectangle are equal. And an extra piece of information which is not given on the diagram is the length of the fencing that will be used to enclose the rest of the site is 140 meters. Okay, so that just helps you to keep track. Sometimes you might have the majority of the work or the majority of the numbers given to you on the diagram. Sometimes there'll be pieces that won't be able to be put on the diagram. So part 1, write an expression in terms of x. So that means the expression will have x's for the length of the side facing the road. Okay, so we're looking for L in terms of x. Now the use of the word expression is a little bit misleading here because we're going to get L equals. So yes, it is an expression for L, but we're going to have to start with an equation. So if I go back to my diagram and just focus on the sides where we have fencing, I have X and L and X. And the total amount of fencing is 140. So when I add those three pieces together, they're going to add to 140. That gives me L plus 2x equals 140. So now I want to get it as L equals and the x on the other side. So we can take away a 2x from both sides and we get 140 minus 2x. That's a bit of manipulation of formula. So this is our answer for an expression for the length. So 140 minus 2x. It is in terms of x. So just be careful when they say an expression for something, because then it's often L equals, or it might be an expression for volume. Just a little bit misleading there with that word expression. Show that the area of the site in meters squared is minus 2x squared plus 140x. Okay, so to get the area, we multiply length by width, which is x by L. Now, that's just XL or LX, but we want to make it look like this. Notice that that expression does not have any L. So we're not going to be able to use L. Instead, we're going to use the expression that we've just worked out for L. When we've seen this in the past, they've often gone, show that the expression is 140 minus 2x. That way, if you can't figure out that part, you still have the answer to continue on to the next part. Remember that this is a sample paper. So instead of L, I'm going to put in 140 minus 2x, and then I'm going to multiply out 140x minus 2x squared, which is what they wanted. It's just written the other way. So let's write it the way that they've asked us to do. 140x. And then we can put a little QED here at the end. It's a little Latin phrase that just means I've done what has been asked. So they've asked us to show that the area is this, and we have done that. So the next question is the Junior Cert Higher Level Paper 2015. This was from a sample paper. A plot consists of a rectangular garden measured 8 by 10, surrounded by a path of constant width as shown in the diagram. The total area of the plot is 143 meters squared. So remember, we're looking at the diagram, we're comparing it to what information we've been given, and we are highlighting or pointing out or really noticing anything that's not given on the diagram. 3 students, Kevin, Elaine, and Tony, have been given the problem of trying to find the width of the path. Each of them is using a different method, but all of them are using x to represent the width of the path. Kevin divides the path into 8 pieces. He writes down the area of each piece in terms of x. He then forms an equation by setting the area of the path plus the area of the garden equal to the total area of the plot. So it was quite wordy. Okay, so the only thing we know from that previous paragraph is that the total area is 143 meters squared. So they then give us this new diagram which shows these 8 divisions, and it says write in terms of x the area of each section into Kevin's diagram below. Okay, so it is of the path. Let's start with the path. The path is of constant width. So where we have this x here, so the x given here, this is also x. So these corner pieces are actually squares. So that means it's x by x, which is x squared. Each of these corners will be the same. So they're all x squared. The middle piece is 8 by 10, which is 80. All of these are meters squared. Okay, I don't have enough space to put in all my meters squared, but they're all measured in meters squared. So my top rectangle here is x by 8. So it's 8x, and it'll be mirrored down below here. And this last 2 rectangles are going to be 10 by x, so that's 10x and 10x. So now we have written in terms of x the area of each section. Part B then says write down and simplify the equation that Kevin should get. Give your answer in the form ax squared plus bx plus c equals 0. So we're going to end up with a quadratic trinomial, a quadratic equation. So we have x squared plus 8x plus x squared plus 10x plus 80 plus 10x plus x squared plus 8x plus x squared, and that should all equal the total area which they gave us at the very start of the question, and that is 143 meters squared. I'm going to leave off the meters squared here. Everything is measured in meters squared. Okay, So now we need to simplify. We need to add our like terms. So x squared, x squared, x squared, x squared. We then have a plus 8x plus 10x plus 8x plus 10x. So we end up with 4x squared plus 36x. So 18 and 18 plus 80 equals 143. It doesn't quite look like what we want yet. We need to make it equal 0. So to do that, I'm going to take 143 from both sides. That will give us an equal 0 here. So we have 4x squared plus 36x minus 63. Now, you might notice that 4 and the 36 have a common factor, but 63 is not divisible by 4. It's not divisible by 2. So this is as simple as it can be. So the next part of this question moves on to the next student. So Elaine writes down the length and width of the plot in terms of x. She multiplies these and sets the answer equal to the total area of the plot. Write in terms of x the length and width of the plot in the spaces on Elaine's diagram. Okay, so here we have the width. The width will be 8 plus x plus x. So we get 8 plus x plus x. So I'm going to write that as 2x plus 8. 8 plus 2x is also absolutely perfect. Then we have the length, which runs here. So we have this piece, which is x plus 10 plus x. So the width is going to be, and I can't write sideways on this, x, I'll write here, x plus 10 plus x, which is 2x plus 10. So then it asks us in part D to write down and simplify the equation that Elaine should get. So Elaine writes down the length and width of the plot in terms of x. We've done that. She multiplies these and sets the answer equal to the total area. So she gets 2x plus 8 times 2x plus 10 and then allows that to equal 143. Let's multiply that out. To do that, we're going to split the bracket. So 2x bracket 2x plus 10 plus 8 times 2x plus 10 equals 143. 4x squared plus 20x plus 16x plus 80 equals 143. 4x squared plus 36x plus 80 equals 143. It's not quite what we want yet. We're going to take the 143 away from both sides. At this point, it might be starting to look familiar despite Elaine and whoever we looked at previously using two different methods. They have in fact ended up with the same answer. So that's minus 63 equals 0.